Okay, we see here the curved end. Excuse the sound. It's set up above the tabletop. Now really it's best to do this where instead of like the wooden ramp here, this is the edge of a tabletop and this is the floor, so that the distance of fall is much greater than I've got here. Trying to keep things on camera and get things set up. This is the best we're going to do right here, but edge of a table, floor, much better. Needs to be a solid floor, not a carpeted floor. Okay, I've got a little section of a straw here, just a little section of straw, and the purpose of this little section of straw is to support one of these metal spheres as close as possible to the edge of the table. Now the rail, or the ramp, is going to be used to direct another ball into a collision with this ball. I want the collision to occur at a point where the two balls are at exactly the same level. That way I can be sure that the balls are coming off of the, or out of the collision in the horizontal direction. So I could take the line level, put it on top of a cassette case or something, and see if we have a good level between the tops of the balls. If not, I need to shorten or lengthen the straw, or more conveniently, simply shim the edge of this ramp here with pieces of paper or something to raise and lower it until the balls are hitting center to center. Then, on the floor where I think the balls are going to hit, I take a piece of carbon paper, lay it down, and then I let a ball come down the ramp. Now, the speed of the ball is going to be kind of important. I start at the edge of the ramp, and in some procedures we're going to actually measure how high the ball is at the edge here, so we can infer how fast it's probably going when the two balls collide. So, okay, the two balls will fall and hit down here. One thing we don't want is we don't want a kind of collision where this ball comes down and bounces off the edge of the ramp and then goes out. That's going to throw things off. And for that you need enough speed on the ramp so that this ball will actually clear. And in fact, that's pretty much not going to happen when the balls have equal mass. Now you'll do this with equal mass balls. You do it with a small ball and a large ball. Small ball here, large ball here. You can also do it with the large ball here and the small ball here, but the small ball just bounces back up the ramp. You should see that. You should at least experience that and see how much velocity the large ball gets. Now, as instructed in the experiment, you're going to measure the horizontal range of each ball to determine how fast it was going at collision. In experiment 20, we do the same thing, but we set the target ball up in a position, and we're going to not hit the target ball center to center. Now, horizontally, the two balls should be at the same level, but this ball is going to hit off to this side a little bit, so that what we get might look something like this. Okay, so the balls go off in different directions, perpendicular to the original path of the first ball. And we're going to study momentum conservation in 2 dimensions using that model.